Okay, hello everybody. Welcome to today's webinar on ElasticBLAST. This is Peter Cooper from NCBI. I'm going to introduce Tom Madden, who's going to be your speaker today. And so with that, I'm going to turn this over to Tom Madden, who's the BLAST lead, and he's going to talk about ElasticBLAST. Take it away, Tom.
Hi, this is Tom Madden. I'm the offering lead for BLAST at the NCBI. Today I'm going to tell you about a project I'm really excited about. It's called ElasticBLAST, and it lets you run your BLAST searches with minimal effort on the cloud. So my main emphasis today will be on what ElasticBLAST can do for you. So this is not supposed to be a tutorial on how to run it. We have pretty good documentation on that, and I'll point you to that documentation at the end of the webinar. First, let's go over the agenda. To start, I'll give you a bit of an introduction and set some context. Then I'll do a demo of ElasticBLAST. That's right, a live demo. Next, I'll show you the range of searches ElasticBLAST can do, how quickly it can do those, and what those cost. Also, we'll talk about minimizing costs and how you can try ElasticBLAST out for free. Then I'll talk about what ElasticBLAST does for you to make using the cloud easier. Finally, we'll discuss resources that can help you. Okay, so first, what is BLAST? Briefly, BLAST compares DNA or protein sequences to a database of DNA or protein sequences. If necessary, it translates the DNA into protein for the comparison. We have a web page, an NCBI web page for BLAST, a command line suite of tools we call BLAST Plus, and some cloud products. So ElasticBLAST is built on top of the BLAST Plus command line suite. This is my one-sentence description of ElasticBLAST. Here I say that ElasticBLAST is a cloud-native package, meaning that we've used tools like Kubernetes or AWS Batch that are maintained by the cloud provider, as well as things like Cloud Buckets, which is just an area on the cloud you can store files in. We use the buckets to store your queries, results, and other files. We've also written some BLAST-specific software to make the cloud easier to use with ElasticBLAST. So this is a list of reasons to use ElasticBLAST. There are a lot of reasons, I think, but I want to emphasize here that ElasticBLAST makes it relatively simple to run your BLAST searches on the cloud and do it efficiently. It can work with both smaller sets of queries and very large ones and do that quickly. Okay, so at this point, I'm going to switch to a live demo, and I guess I just like to live dangerously. Okay, so in this demo, I'll look at a set of proteins from a WGS, or whole genome shotgun, woodchuck project that are mostly labeled as hypothetical, meaning that we don't really know what they are. And I'm going to search them against high-quality refseq select protein database. I'm also going to limit that search taxonomically to mouse. To do that, I first need a configuration file for ElasticBLAST, and I'll show you that to you right now. Okay, the configuration file has 3 sections. Well, actually, let me step back. So as I mentioned, we have pretty good documentation and tutorials that walk you through your first search. So don't sweat all these details right now. I'm just gonna sit back and absorb them. Okay, so the configuration file has 3 sections. The top one, Cloud Provider, which I just highlighted, just provides some information about where this is run. In this case, it just lists the AWS region, US-East-1. And there's really not much to do there. In the second section, the cluster one, this is where you can put in information about the number of instances you want and other cluster-specific information. In this case, I've asked for 8 machines or nodes, and also to run this as a spot instance, which is what this preemptible means. Spot instance just means that you'll be running a little bit cheaper price, and I'm going to come back and talk about that, the details about that later. So don't sweat the details exactly right now. Finally, the third section has BLAST-specific information. And so first, the program is BLASTP, which compares a protein query to a protein database. The database is listed as refseq select prot. This is a high-quality, carefully curated database produced at the NCBI. For the queries, we have a path to a cloud bucket on AWS. And this is basically disk space you can use to store files pretty cheaply. And so I just have the FASTA files up in this cloud bucket. The results also go into a cloud bucket. This is where I'll find them when the search is done. And then so finally the BLAST options. And I put down here task BLAST-P-fast, which is just means that I want BLAST-P to run in a faster mode. And it's normally, this is really what you should be running. I've set the expect value pretty low, meaning I'm going to look for matches that I think are really significant. So here you also see the out format option 7. And so what this does, this will produce tabular output that includes some standard fields, the length of the query, and the database sequences, not the length of the alignment, but the length of the actual sequences. The query coverage per subject sequence, the tax ID of the match, which is just in the tax ID, is just an integer. And every node in the NCBI taxonomic tree has a tax ID assigned to it, as well as the scientific name. So finally at the end here, and this actually wraps around, it says dash tax IDs 10,090. 10,090 is a tax ID for mouse. So I'm actually going to limit my searches to just mouse. So one thing I want to do before I run this is I want to take a check of what version of ElasticBLAST I have installed here. So here it is, ElasticBLAST 0.2.2, which is the latest version. ElasticBLAST is pretty new, and so we're updating it as issues get reported to us. So I always suggest using the latest version and not letting that lag. So now I can want to submit my search, and I'm just going to copy and paste here so that you don't have to watch me type. So I execute ElasticBLAST with the submit command, and you see there ElasticBLAST, and then the keyword submit, token submit, and then config, and this dash config parameter to point to this woodchuck_mouse configuration file that we just looked at. And so I hit return, and this takes a minute to set up. This takes a few minutes to return as it waits for resources to be prepared. And then the whole search takes about 20 minutes, so we're going to look at some results I prepared earlier. And actually, I'd like to let this return. So you also see some messages here that will tell you that, that basically you can ignore these. There's something about the AWS limit checker, something about GP2. None of this is really that important in this case. Okay, so I'm going to put this in the background so I can get on, and I'm going to kind of look at the results that I produced earlier. And so first of all, I'm going to make a directory here and CD into it. And this directory is just the name of the WGS project. And that's, for people familiar with Linux, that's pretty standard. So this next part is a little bit trickier. AWS has a command line interface, and GCP has something similar. And in a way, they kind of mimic Linux. If you haven't seen them before, they look kind of familiar to Linux, like this one here, AWS S3. S3 is what AWS calls their buckets. And then copy, just like you would have copy. And so it's going to copy the results of what's in this bucket and do it recursively and to the current directory. So let me do that. And so it happens pretty quickly, and you'll see that there are a lot of files here, and this has to do with how ElasticBLAST processes the queries. And so let me just do an ls here. And so the first thing I'm going to do is I'm going to run this gunzip command to simply put all the files together into a file called woodchuck_mouse.tab. So this is basically gunzip-c is going to concatenate all the contents of those files into this one tabular file. So we can take a look at the tabular file now. And so you're going to see some lines start with a hash mark. And those are just additional data that we can ignore right now. And if I go down here a bit, so here you're going to see a number of significant matches, and so this is the query ID. This is the database, ID of the database sequence, and there's a whole bunch of fields here. And this is 94% identity, and the length of the alignment is 700 residues, and so this is kind of going on here. And you don't really need, so you could look at this, but really this tabular output is more meant to be processed with some sort of script. And so what I'm going to do is I'm going to, I wrote a quick Python script. And so what I'm going to do is I'm going to execute the script. But before I do that, let me tell you a little bit about what the script is supposed to do. So I've written this script to look for alignments that show at least 50% identity, and that's one of these fields up here that you can see. The query and the database sequences are supposed to be about the same length, and since I asked for that information to be printed, I can calculate that also. And also that 90% of the query is covered by a database sequence. And so let me hit return here. And so running the script, I see my alignments that meet my cutoff, and that they're just streaming by. So I'm not saying, now I'm not going to say that this is the best way to filter alignments. I'm just saying you can do it however you want, and just kind of demonstrating that. And I'll also say that this tabular output is something that you can produce, is actually produced by the BLAST Plus executables that underlie ElasticBLAST. So you could do this with a standalone BLAST Plus command line. You could also do it with ElasticBLAST. And really, this tabular output is very flexible. You can get lots of different fields in there. You can even get sequence in there. Okay, so now that I've done that, let's, the demo has worked without incident, apparently. So let's go back to the PowerPoint slides. Okay, so in December, I tried out an ElasticBLAST run from my personal GCP or Google Cloud Platform account. It was the example in our quick start, which is the first search we suggest people do. A few days later, the bill arrived via Gmail. Well, of course, but as you can see, it cost all of $1.94 to run those BLAST searches on the cloud. I thought, cool, this is cheaper than coffee. It turns out I was wrong. You can get a basic tall coffee at Starbucks for $1.90 or so. So this statement only applies to grande or larger. I just want to make sure that, I have this right. Okay, despair not though. Next, I'll talk about how you can run the search with mechanisms that allow you to pay a fraction of the full price. I don't want anybody to have to give up their coffee. That's generally not a good thing. Next slide here is instances at less than full price. So both AWS and GCP have a mechanism where you can bid on instances at less than full price and use them at that price if your bid succeeds. With AWS, they are called spot instances, and the rate varies between 10 and 100% of full price. I did a few runs last week and ended up with prices about 1/3 of full price, but like I said, this may vary. With GCP, they are called preemptible instances and go for about 20% of full price. Caveat is instances may not always be available right away. ElasticBLAST will use spot or preemptible instances if you ask it to do so. So that makes it easy. And you might recall I had simply put that in the config file when I did my run. I said use preemptible. Okay, so finally, here are some example runs. Now my idea here is to show you a sample of different searches that you can do with ElasticBLAST. That's why I'm presenting a range of searches. I've listed the size of the query and database, how many CPUs were used, the time to run, and the cost. I have searches done at both GCP and AWS. That's in the provider column here. And I'm going to go through these rows, and we'll have a red diamond to the left of the row I'm discussing, like this for the top row. So in the top row, we're finding conserved domains for 3.4 billion bases of human gut metagenome. Yes, I did say 3.4 billion with a B. And for this, I brought up 132 CPU instances and got the results in a little more than just 2 hours, 2 hours and 15 minutes. It would have taken more than 4 days just running this with 32 threads on a single machine. The total cost of the run was $270, but it could be less with preemptible instances. Okay, the second row is a quick start run I mentioned earlier. So we have pretty good instructions on running the quick start at AWS and GCP in our documentation. And this is the first search we suggest you run. You can try it right after this webinar if you want. And as you can see again, it takes about 30 minutes. Cost was at GCP was $1.94. Preemptible cost should be about 38 cents. The third row is a search against NT, or the nucleotide collection, which is the single most used nucleotide database at the NCBI. It's not small at 662 billion bases. The query is also relatively large at 82 million bases. And it's a collection of all hepatitis sequences I pulled out of NT about 2 years ago. And this can run for under $5 if you use spot instances. And at this configuration, it takes about an hour and a half to run. And I probably could have actually added more CPUs and run this a little bit faster. Okay, so the fourth row is a search of the RefSeq select database, limited amount sequences. ElasticBLAST supports taxonomic limitations, so it's not a problem to limit to mouse. And this looks familiar because it's the example I did in the demo. As you can see, runtime is about 21 minutes, $3.30 for the cost at real cost to run, and as a spot instance, it could run about 94 seconds. And so, and the number of CPUs is 128. And so finally, least but not last, the last row is a search of some proteins against a popular NR or non-redundant database. This run costs about $2 here and could run in 48 minutes. It's 65 cents as a spot instance. And I'll just actually add that the NR database is actually pretty large. It's about 175 billion residues. This is more kind of a smallish query at only 57,000 letters, at least smallish by ElasticBLAST standards. Okay, some notes on where these cost estimates come from. So for the GC, so I did these runs and calculated the cost based upon how long they took to run. The GCP preemptibles, I simply calculated that as 20% of the full cost. For the spot instances, I actually did both the full price run and the spot run, and then I'd go and look at what's the cost of a spot instance of that spot instance at that point in time. And AWS gives you a web page to do that, and I have a link to that later on at the end of this webinar. And so these costs, basically the spot instance costs were from last week, Thursday and Friday. Okay, so as I mentioned earlier, both GCP and AWS have a free tier or free trial. They use different terms to let you try things out. This is time limited, but that time is in months. There are also limits on resources. And so we have documentation of how to use ElasticBLAST under those constraints in our documentation. And I've got a link to that at the end of this presentation. Okay, so on the right side, I have a table. And this table is the start of a list of all the different instances that you can use at AWS. And GCP has a similar table. So the good news is that you don't need to look at the 443 different instances instance types before you run ElasticBLAST, because ElasticBLAST will do it for you. Now, the most important question about whether an instance will work for BLAST is whether it has enough memory. The question then becomes, how much memory do you need to run a BLAST search? And the answer is that it depends upon the database. So basically, you have to have enough memory to hold the database in memory, and that determines which instance you want to use. So to answer this question, which instance you want to use, we've introduced metadata for the BLAST databases in JSON that includes the memory needed to cache the database. ElasticBLAST then adds more memory to that amount for the program in OS and finds the smallest instance that will be able to efficiently run your search. Now, of course, you can still specify a machine type if you prefer. You may just have to go through a long table. Okay, so this is the JSON metadata for a small database we provide. At the bottom, you can see bytes to cache, which helps ElasticBLAST pick out an instance. And bytes to cache basically tells ElasticBLAST, or could tell you, how much memory you need, and then you just add 10 or 20%. And you'll notice that there's also like a date stamp here and details about the size and description of the database. This metadata comes with all NCBI provided databases. If you use your own database, you can produce the metadata with a Python script that comes with ElasticBLAST. Starting with our 2.13 BLAST Plus release, the metadata will get produced when you build your own database. We expect to ship 2.13 sometime in March now. Okay, so some notes on the databases that we have, the NCBI databases. We host 28 NCBI databases at AWS and GCP. ElasticBLAST knows how to find and use these. These databases range from the REST-seq eukaryotic database down here with over 1 trillion bases down to a much smaller 16S database, as well as databases for the human and mouse genomes. Okay, so here are some links to help you get started. And I recommend starting with the top one here. And that will introduce you to ElasticBLAST, some cloud concepts, and then guide you to a quick start to try things out. If you're already familiar with the cloud concepts, of course, you can skip over those and just read about ElasticBLAST. Okay, so this is a list of resources that I've mentioned throughout the talk. The GitHub page has the source, that is Python code for ElasticBLAST. You can also open an issue through GitHub. The second to last link for ElasticBLAST demos down here has a script to run ElasticBLAST and download the files for you so that you don't have to actually manually run these AWS or GCP command line interface commands. And we'll probably be adding more demos to this site. The last link lets you see the current cost of spot instances at AWS. And I understand that's updated like every 5 minutes or so. And most of these other links are pretty self-explanatory, but I invite you to explore those. Finally, so let us know how this works for you. We are actually excited to hear from you. Let us know if you find a problem so we can fix it. And so I've listed an email address, but you can also open, so this email address here, you can also open an issue on our GitHub page. And so that's it for me, and I guess I'll turn it back to Peter right now, right? See if there are any questions.
So, thanks, Tom. Yeah, this is Peter again. So a couple of questions, Tom. We were, in thinking about costs, somebody actually asked me in the chat, can we get it for free? And I answered in a way that basically the program's free, but the cloud instances are not. But do you think you can actually run some of these searches that you showed on the free tier?
Well, so you can run ElasticBLAST on the free tier. So the issue is on GCP, for example, they limit you to using 8 CPUs at one point in time. So I actually tried that out, and I did actually do a run. I actually had to. What I did was I had to actually specify an instance that was a little bit smaller than we normally tell people to use. And I also went for the Swiss Pro database, which is fits well into that instance. And we actually have, so right here, this link here, GCP free trial tips. I've documented what I did, what you need to do to try that out. And yeah, and like I said, this is a time limited thing, but it kind of lets you get in there and give this a try. And I think it's good for 90 days or something. And I think actually in AWS, other people have actually used their free tier to try things out.
Okay, so then another question is about, I'll just read it to you because it's got a lot of detail in it. It sounds like ElasticBLAST is an alternative to setting up the BLAST Plus executables in the cloud, say with Docker. Is that true? Are there programs or options we'd be missing if we use ElasticBLAST?
Yes, it is I guess you can think of it as an alternative. It kind of makes it simpler to set up. And you could use Docker, or you could also use just the BLAST Plus command line binaries, which I have the impression a lot of people do in the cloud because it's just a Linux binary. We've tried to, I think we've included all the programs. We might have, a few we might not have done, like Delta Blast and such. There are still some options in ElasticBLAST that are missing. For example, you can't limit your search by a GI list. This came up recently. These are things that actually could be implemented if we hear back from people that, hey, I think ElasticBLAST is good, it works well for me, but I need you to implement this. So really, it's kind of, we're reaching out to people now to know, is this useful for you, and what would make it more useful for you? So let us know.
So it's an alternative to the regular BLAST Plus executables, but there are just a few options that are not supported, basically.
Yeah, and it's actually, to be clear, it's actually a wrapper over the BLAST Plus executable, so it's actually not that difficult for us to add things. We just need to make the time for it.
Okay. Another question is, when you use these preemptible instances, it's possible that, if I understand how that works, it's possible that the cloud provider could basically just take one of your machines from you. Is that not true? So
that is true. Is that they could shut down your machine. And I think it depends upon the cloud providers. I think one of them will only turn it off, won't turn it off for the first hour, and the other might turn it off sooner. But if the way this works with the, since we're using Kubernetes and GCP and AWS Batch, if a machine goes away, ElasticBLAST will realize that and decide that this machine has failed and start a new machine to replace it. So in principle, it should work. It should continue to work. It would could be a problem if the, if, for example, that no preemptible or no spot instances are available.
But it sounds like it sounds like ElasticBLAST takes this into account and is flexible enough to deal with that. So that's interesting. Yeah.
Yeah, so it's resilient, and mostly I'd say it's resilient because we're leveraging Kubernetes and AWS Batch that want to be resilient against stuff stuff happening in the cloud.
Okay, and there's a question about integrating ElasticBLAST into a Nextflow pipeline, and Christian did answer that in the questions pod. I don't know if you have any comments to that. Christian says he doesn't see why you couldn't do it, but we haven't tried it.
No, we haven't tried it, but I think that's a great idea. If somebody has an example, maybe we can go to the example page or something. Maybe we can do an example ourselves. So that's that would be great to hear about.
Okay, well, I think that's everything that we have in the questions pod for now. So thanks everybody for coming. I'll go ahead and end the webinar for everybody, and we'll talk to you next time. Thanks, everyone.
Okay, thank you.
Okay, bye.